In the figure below, we have L1, which is line 1 is parallel to line 2, and line 3 is parallel to line 4. And it's asking us what are the values of W, X, Y, and Z. So again, you want to start off with the angle that they gave you, which is 110. And notice that we have vertical angles with Z, so Z is 110. Okay. Now, I would like you to try to, in your mind, only view L1 and ignore L2. And if you notice, the 110 is the obtuse angle in the picture, and angle W here is acute. And we know that if we have two parallel lines cut by a transversal, that the acutes and the obtuses are supplementary. So to figure out angle W, what we can do is take 180 and subtract 110, and we will get 70. So now W is 70 degrees. And I'm sorry, this picture's a little scrunched up. Now, if we kind of rotate the picture or think about looking at it from the side, we'll also notice that we have, let me actually erase some of this because it's a little messy and I want to actually blow it up. That's better. So let's see if we can do this with this picture. So we have 110 for this angle and we have 70 for that angle. Now what I would like you to imagine is that these are now the parallel lines, which they always were parallel. And now we have, say this line is the transversal. So if you notice, we have this obtuse angle, which is 110, and we have this acute angle, and we know that obtuses and acutes are going to be supplementary. So basically, angle Y is 70 degrees, just as angle W is also 70. And the same thing now applies. We have the 70, which is acute, and this X, which is obtuse. So that is also 110. So if you notice in this picture, we get a figure called, this, you're not responsible for this, but we get a figure called a parallelogram, and the opposite angles in a parallelogram are equal to each other. Again, this is a harder problem. We didn't cover one quite like this in class. This was meant to be a challenge.